science,
engineering,
medicine,
chemistry,
physics,
biology, humanities, cardiology,
computing, public health, global
science communication.
Hello everyone, I'm Gareth Mitchell. Today, the latest on coronavirus as Imperial experts join in the global research effort and keep the advice up to date for governments and our health service. Also in this edition, the shopping trip for baby food that led to a nutritious idea for a business.
I started thinking about baby food because of my godson, and I was looking for something nice looking like a puree. I couldn't find anything, and then I ended up looking at all those flashy looking pouches and realized, wow, they have a shelf life of 2 years, and my godson is not even 6 months old, so this is literally food that's older than a baby.
An Imperial alum tells us about her sustainable business providing an alternative to mass-produced, processed baby food. And also, how do you design for life on Mars?
The Imperial College Podcast.
OK, now we'll be talking about COVID-19 in just a moment, dominating the news obviously here at Imperial and nationwide and globally. But first, newsworthy science elsewhere, and Hayley Dunning's here. And Hayley, this is a study that says discouraging things about bee development.
Yeah, this is quite a sad study that looked at the impact of certain kinds of pesticides on the brains of baby bees. So you probably know that a class of pesticides called neonicotinoids have been causing some concern about their impact on bee colonies. And this study was a little bit different in that it didn't look at bees who are actually going out and foraging for flowers where pesticides might still be, but instead looked at what the impact might be when that food is brought back to the colony. So when that pesticide-laden food is fed to the youngest members of the colony. And sadly, this shows that it actually impairs their brain development and causes them to have learning difficulties later in life.
So what did the researchers do in this study?
So it was quite an incredible study because what they actually did was micro-CT scan bumblebee brains, which, as you can imagine, are incredibly small. And so they managed to image these brains, and not only, the brains as a whole, but some of the different structures in the brain. So there are these certain structures called mushroom bodies, which are associated with learning. So what they managed to do was actually test the size of these mushroom bodies in some of these bees that have been fed pesticides. And also they did an incredible test to see if those bees were able to learn. So what they actually did was see if the bees would respond to a smell that would be associated with food. So in a classic kind of learning test of whether they could associate that smell with food. And they found that a lot of those that were exposed to pesticides just couldn't do it as well.
And indeed, as you mentioned there, Hayley, pesticides and bee populations, especially relating to neonicotinoids, well, they've really been on the agenda, haven't they?
Yeah, so for a long time, people have wondered about the link between these neonicotinoid pesticides and bee colony decline. So this class of pesticides, some of them are actually banned for outdoor use in the EU at the moment, but they're used widely around the world. And the researchers kind of want to know, are there any safe levels? Is there a way we can use this responsibly, or are they just that damaging?
All right, Hayley, thank you very much indeed for that. That's Hayley Dunning. We'll hear more from you a bit later in the podcast, actually, Hayley. Meanwhile, Caroline Brogan is here. Now, Caroline, how about this? We're going to be talking about the UK Fireball Network. That sounds fun.
Yes, Imperial and the University of Glasgow have set up a UK Fireball Network. Now, this is a network of cameras around the UK that looks to capture images of falling stars, essentially. So meteorites from out of space that are falling onto the Earth or into the North Sea. They're also looking for volunteers too, people who want to help scour the nation for these falling stars once they've hit the ground. The meteorites could ultimately help us understand our own planet, solar system, and maybe the wider universe.
So has anybody found anything already?
Yes, back in February 2020, the network's cameras in Lincoln and Cambridge both saw their first fireball, which dropped into the North Sea. While those meteorites are impossible to recover because they're in the sea, the network team expect that future sightings that fall onto the UK landmass can be properly triangulated to determine a landing area and send out a search party to find the falling stars.
Well, that would be great. Mobilise the search party. Caroline Brogan, thanks for that. Now, if you want to be a volunteer to help the researchers track down those meteorites, then there's a mailing list that you can join for the UK Fireball Network. And the quickest way to get there is just to type Fireball into the search box on the imperial.ac.uk/news website. There you will find Caroline's rather marvellous article on the whole topic. And from that article, you can click through and join that mailing group and join the hunt for some meteorites. Well, to coronavirus now, and a word with an Imperial expert on the subject, specifically the epidemiology of the disease. And of course, we're learning something new every day. There are echoes of the 2003 SARS outbreak and even the 2009 flu pandemic. But with COVID-19, the spread is greater than with SARS, so it's proving harder to contain. The 2009 flu pandemic spread quite extensively but had less severe symptoms. So what about the numbers this time round? Just how fast and widely is the current disease spreading? Ryan O'Hare has taken that up with Azra Ghani, Professor in Infectious Disease Epidemiology in the School of Public Health.
Two key factors there are something we call the reproduction number, how many people on average each person goes on to infect. We think that's around 2 to 2.5. That's relatively high, but very similar to other infections like flu and SARS. We also know something about how rapidly it will spread. So it seems that the epidemic, if left completely unmitigated, we'd expect case numbers to double approximately every 5 days.
So with this outbreak, we've seen a huge volume of data. There's preprint papers out there, and there's data coming out every day from a variety of sources. How do you work out what's good data and what's bad data?
That's actually a really interesting question and something we have found quite challenging at this particular time round. So the only way we can really approach it is to have a very large team, probably 50 plus people now working on this particular virus. Students, postdoctoral staff have been absolutely fantastic in doing jobs that maybe aren't as scientific, but just involve data entry or reading another paper, summarising that and really trying to give us the best possible sense of all the scientific information that's out there.
And throughout this process, your team has been modelling different aspects of the outbreak, everything from, as you said, the transmission rate to the fatality rates. How do you go about generating these models?
Well, much of the computer code that we would use for this has been developed over a number of years. There's been pandemic planning models developed within the department for many, many years now. A lot of the tools are there, but what we find is that every little bit about a new disease is slightly different. The data will have a slightly different format, or the statistics that we need to use need to be very slightly modified. So whilst we have a lot of this machinery ready to go, it isn't really a case of just pressing a button. It requires quite a lot of scientific input.
What are some of the biggest challenges facing the team at the moment then?
I think actually at the current time we don't really have any sense of the role of children in transmission. We know that children are at relatively less risk of developing disease, and we don't see that many cases compared to the size of the underlying populations in anyone under the age of 20. What we don't know is whether they're getting infected and potentially transmitting disease to others, or whether they're completely immune to it or mostly not susceptible. From a scientific perspective, that is challenging, because what we have to communicate back then to those making decisions that have a wide impact on society and the economy is that actually we just don't know. Until we do this, we won't really have a good assessment. We are hopeful that there has been quite a substantial process with developing serological tests. They are tests that detect whether someone has been infected in the past. If they can be applied rapidly across the population, and I know there are plans in place in the UK to do so, that will give us that piece of key information that we're looking for.
And how far behind everything else are these tests? When might they come along?
My understanding is that they should be available in the coming weeks, and that populations around the world are starting to test. So we should get that information soon, but unfortunately we're probably going to need to act in some way to mitigate spread ahead of having that key piece of knowledge.
So in terms of the reports and the data that your team pulled together, why is this important? How does it influence what the government does or what the health system does?
Well, a number of my colleagues, in particular Professor Ferguson, sits on advisory committees for the UK government. So through those committees, These reports are shared generally ahead of time as soon as we have information, and that is fed in, as well as to directly inform NHS planning, because these models can produce fairly detailed estimates of potentially numbers of people that would be hospitalised.
So is your work informing things such as whether we should close schools or things like that?
We've looked at a whole range of different mitigation scenarios. Closing schools is one of them. Other ones just involve trying to encourage people to work from home, for example, as a measure of what we call social distancing. So what we do is we simulate all of these different scenarios, and all of those things then can be fed in to the committees and then ultimately to the people who need to make these tough decisions.
And I guess finally, there's been such a huge amount of public interest and media attention around COVID-19. Do you think that people are getting an accurate picture of the severity of the outbreak, or is there a lot of sort of media panic around this?
I think it's actually been much better than in previous epidemics that I've worked on. I think possibly the reason for that is obviously much more widespread use of the internet and different social media. Clearly there's a lot of misinformation out there, but on the whole, I think from the trusted websites that one might go to, I think the information that's going out rapidly. And I think that's very important because it's good for the public to be aware of all the data that are being generated, even if some of these figures can sometimes appear somewhat alarming.
Azra Ghani speaking there to Ryan O'Hare, and you can hear the full version of that interview via imperial.ac.uk/news, and that's part of a piece that Ryan's written, a really excellent piece. It's called Crunching the Numbers for Coronavirus, so seek that out and you'll hear the full 10-minute version of that audio there as well. Well worth a listen. Well, now, an Imperial alum who became a godmother, and then that led to a rather bright business idea. With more, here's our reporter, Joanna Wilson.
This week, it's Enterprise Week at Imperial, where we're celebrating all things entrepreneurial at the college. And we're actually here with a successful founder of a business, Nadine Hellmann, who is a graduate from Imperial College Business School, who's here to tell us more about her business, Little Tummy.
So the journey of Little Tummy all started back in 2017. I became the godmother to my best friend's baby. And this was the time I realized how bad the situation on the baby market looks, because all you can find out there in the supermarket is heavily heat processed baby food. So they heat it up for hours to make it shelf liable for the next 2 years. So in the end, there's nothing left of the natural goodness of the ingredients, and you lose all the authentic taste, which is actually the exciting part if you introduce solids to your baby.
And what does the business do?
Little Tummy is actually combining medical expertise and leading food tech to retain all the essential nutrients and fresh taste of each ingredient. So instead of using heat, we use pressure, which literally means what's happening is that we squeeze down all the bigger molecules like bacteria in the food to make it safe and to naturally extend the shelf life to 2 months. But at the same time, we're keeping all the smaller molecules like vitamins, which is quite amazing. And my co-founder, Sophie, she's a pediatrician. So she makes sure every ingredient has a purpose, and we support babies in their development.
So now going back in time a little bit, could you explain what your connection to Imperial is?
I'm an alumni of the Imperial College Business School, so I did my master's in management here. I started in 2016 and then graduated. I was focusing on digital business, and Imperial then helped me also in their entrepreneurship course to develop the idea of Little Tummy a little bit further. So I really had a chance to challenge the idea with fellow students, with professors, and we actually won then the entrepreneurship award within the course, which was quite amazing, and that really gave me a push to further pursue it.
Great. So you talked about the entrepreneurship award. In what other ways did Imperial help on your entrepreneurial journey?
I think it really gave me a great starter toolkit. I've studied politics before, so literally I had no idea about accounting, how to set up a business plan. I had experience in marketing before, but not in a very structured way. So it really gave me a toolkit, and I was able to create my first pitch deck and business plan.
What do you think the most important thing you learned during your time at Imperial was?
I think that you don't have to be an expert when you start a new project. I think you must be willing to get your hands dirty, read a lot of books, but I think most importantly, meet a lot of people who are experienced in that field. We did so many diverse projects, and every time we had to start kind of from zero. And I think this really shows it's often more about hassling than having actually previous experience.
Earlier this month, it was International Women's Day. So what advice would you give to other women thinking about starting a business?
First of all, if you found your business straight from uni, I think it's essential to start building up your network and get feedback on your idea. So really, as soon as you have the idea, and even if it's just, writing it down on a piece of paper, don't be shy to write people a short email asking them for an advice or a coffee. This really helps to challenge your idea and to get a better understanding of the market. If you're ready then to go out and fundraise, it's still a man-dominated world out there. So be brave to get your idea across. And then the other thing is that you should support yourself by friends, family, not only believing in the business, but really supporting you also on a mental level. And then you really need that crowd who's like cheerleading you. And, most importantly, build a great team around you, because these are the people who help you to really bring your idea to life. So that's crucial. And they will challenge your idea on a daily basis and your viewpoints, which I think really is pushing then also the company to the limits and to innovate faster, to be faster, to be more successful.
Going forward, what are your goals for Little Tummy?
We as a team at Little Tummy really want to grow it to the leading honest food company for baby and children's food. We're really eager to kind of change the game and provide parents with a better solution that's really nutritious yet convenient.
Nadine Hellmann talking there to Joanna Wilson. Well, finally, here's a question. Would you like to move to Mars?
I would love to move to Mars. It would be super, super cool. I think it would have to be a change in attitude to how we do things, not just kind of, we've ruined Earth, let's find somewhere else to ruin.
Not yet. Doesn't look too comfortable, too friendly, but maybe one day.
I would very much like to visit Mars, purely out of interest. However, I don't see myself being one of those dedicated people who give their life to make the colony better.
Would you go to Mars?
No. No, I don't want to go to Mars personally. When you start to really think about what would it be like, and then you think, well, what would I do today? And all the things I love on Earth to be left behind, I just couldn't do it.
Yes, differing views there, but all those people were at a recent symposium about the challenges of moving to the Red Planet. Hayley Dunning was there.
I'm at the Design Museum for a Designing for Mars symposium that's between the Design Museum and Imperial College London. So I've caught up with some of our scientists. First off is Dr. Jonathan Eastwood from the Department of Physics, who's also head of our space lab. Now, you were talking about space weather, and when we're thinking about moving to Mars, what is space weather and why is it important?
So everyone thinks space is empty, but it's actually full of particles and radiation and all sorts of things. And this is all driven by the sun. And so solar flares and mass ejections can travel through space, and they generate radiation, which could be harmful for astronauts travelling between Earth and Mars, and also on the surface of Mars, because Mars doesn't have a magnetic field like we have at Earth.
You can imagine that radiation affects humans. We sort of know the long-term effects of cancer, but how does it affect electronics and equipment?
Right, so the particles can embed themselves in the electronics controlling the spaceship. And this can cause electrical discharges that can corrupt the memory or stop them working. And so you have to design systems that can withstand all of this stuff, as well as worrying about how it would affect the people themselves.
Now, I know you're also talking about that you're part of a mission called Lagrange that will put some equipment out in space to monitor the situation on Earth. And if we move to Mars, would we need a similar system to check out what's happening there?
Yes. So at the moment, space weather is a very big area of interest for the Earth, and there's a lot of work going on to have satellites monitoring around the Earth. The next step is having a more interplanetary system, and so Lagrange is part of this. It's designed to look towards the Earth, but it would also monitor the solar system more generally and would form the basis for also monitoring Mars and other planets as well.
As well as designers and scientists, there are students from the joint masters between the Royal College of Art and the Dyson School of Design Engineering at Imperial. They've been taking part in a makeathon, a 48-hour challenge, to come up with design concepts for moving to Mars.
I'm Anaïs.
And I'm Pilar.
We designed a system for the initial colonization of Mars. The idea would be that we have moving vehicles called nomads, which would act as temporary homes for the travelers.
One of the main problems that we found is that if we go to explore Mars, we don't want to come back to the base every single day, right? That would basically waste so much time. So what if this was a moving home? Then we would go back to the beginning of the humans like traveling around and moving with their homes. So one of the main problems here is that we needed to make the habitat the lightest as we could, because that means that we will have energy efficiency, and we did all that by using Autodesk generative design plugin. So that gives us the minimum mass required and the structure in order to meet certain requirements.
So my name is Alberto.
My name is Patrick Gonda.
We thought about the fact that in space, for example in the ISS, you don't use your legs that much. When you have to go around, you just use your arms. And when you have to carry something, your mobility is limited by the fact that you have just one hand free. So what astronauts do in space right now, they carry stuff between their legs. So what we thought was trying to do something to use our legs in space. Our device can be used to attach to handles present in the ISS to move around with your legs, or you can attach something to your feet and carry around the ISS, or with this device you can attach to some kind of fixture so that you can tighten the bolt and do whatever you have to do freely.
How did you come up with this design?
And this was inspired by the talons of a bird. So when you tilt it forward, it opens up, tilt it down, it closes up again. The idea is that birds, they can fly, but also grab things with their talons. So now that humans can fly, we need our own talons as well.
Hi, I'm Max. We started to work on clothing on Mars, and then we decided that if we can make a shoe, we can make any other clothes, because shoe has the most different types of materials in them. So we're essentially trying to use bioplastic, mostly potato-based plastic, to 3D print and manufacture through stamping custom shoes that can be worn on Mars.
Why do we need new kinds of shoes for Mars?
Because currently the fashion is very non-circular, especially the sneaker and shoe department of fashion is extremely wasteful of natural resources, and when we move to Mars we will need to have a very circular economy, because there are very little resources and mostly what we bring from Earth will be what we're using, and we need to make sure we can recycle and remanufacture all the products.
Yes, the need for recycling on Mars there. That report from Hayley Dunning. And that pretty much wraps up business for this edition. But before I go, of course, it goes without saying, there is loads on coronavirus via our news website, and the team are keeping that up to date. So do keep checking that out. That's via imperial.ac.uk/news. As for this podcast, well, of course, we are around pretty much wherever you want to find us on all your favourite platforms, we hope. iTunes, Spotify, YouTube and SoundCloud. And we do visual podcasting via Entail, kind of pictures on the radio, in a sense. Do check that out. Well, I'm Gareth Mitchell, saying thank you very much indeed for listening to this edition. Do take care of yourself, won't you? And I'll see you in a month's time. Bye for now.